Okay, take a look. Two figure skaters are preparing for the grand finale of the performance. The 80-kilogram male skater is staying on the left, and the 60-kilogram female skater is staying on the right. The two are facing each other at rest when the male pushes the female to the right with a velocity of 4.2 meters per second. The mass of the female was 60. Okay. What's their V initials? 0. Just one or both? Both. Right? Both people are staying stationary to start. So both V initials are 0. What V final do we know? Who's that for? Male or female? Female. Okay. We need to find the final velocity of the male. Okay. Now, before we move on to finding this, let's answer the second question, because I tend to forget the second question all the time. All right, so, second question. How does the force exerted by the female skater compare to the force exerted by the male skater? Now, the male has a bigger mass, right? And he pushes the female that way. How do you guys think the velocity of the male will compare at the end? Will it be more or less than the female's? Less. Okay, it will be less. Good prediction. It will be less. You guys are correct. So, the female is going to have a higher velocity than the male after the collision. After the push. Right? So what do you know about their forces? Who gets the bigger force? You sure?
Yes.
But the male has less velocity, so shouldn't the female be pushed more?
Yeah, but she has bigger velocity, so it evens. Right?
So she has a bigger velocity, so they have an even force?
I was thinking about momentum.
You are thinking about momentum. That's a good way to think. Okay? Momentum is what? Conserved. So right now, what's their momentum? 0. Right? When they push off each other, they're going in opposite directions. How does the momentum of the girl compare to the momentum of the man? How's the momentum of the female compare to the momentum of the male? They're equal, but opposite directions. So since the male skater has more mass, his velocity is less. Since the female skater has less mass, her velocity is greater. So that way their momentums are equal. Okay, does that make sense?
What about the force?
Okay. Well, if they both have 0 momentum right now, right, they end up with equal and opposite momentums. Their change in momentums are the same. Right? Remember, change in momentum impulse equals F delta T? So if they're changing momentum to the same, that means their forces are also the same. Now there's an easier argument here. What's the easier argument?
Time.
No. Instead of going through all the momentums, what's the easier argument? Newton's third law. Male pushes on female skater with some force. Female skater pushes back with an equal but opposite force. Okay? So Newton's third law is an easier argument there. So, let's talk about the problem. Who's got the bell?
So if I get like hit by a truck.
The bell. Something's dinging. Is that your necklace?
Oh, yeah.
Alright, what?
So if I get hit by a truck, I'm exerting the same force that's exerted on me.
You are. You and the truck exert equal forces on one another.
Even though it runs me.
Even though it runs you over. Isn't that crazy?
I don't believe that.
Yeah.
Oh,
Newton's third law, how do you not believe it?
No, because if Richard for himself is getting run over by a truck, I'm not gonna oh man, like you literally equal force in the truck.
He does. Okay? Richard accelerates more though because he's lighter.
Third gear. I mean, he's not accelerating because he jumped in the truck.
Okay. So,
Third gear. Think about a deer when you did a deer.
guys, back to example 20.
I was trying to help your team, Brad.
Thank you. Back to example 20. So the two are together to start. So mass of the male plus mass of the female. They're one mass to start, and then they break apart. Oops.
Oh my God.
Right?
Why are they one mass?
Because they're standing there touching each other. Because they'll have the same velocity, right? You can treat it as two separate masses if you want to, Kevin, but then you're eventually going to end up combining like terms anyways. Okay? So they're stuck together to start. They're like one mass. So 80 plus 60 was what? 140. Thank you. What's their initial velocity? 0. They're at rest. Okay. So, Richard, stop talking. Mass of the male, ADV, plus mass of the female, 60 times female's velocity. Right? Now we need to solve. I got the left side. 60 times 4.2?
252.
262?
52.
252, and I got 2060. Got two different answers here. Let's check. 60 times 4.2. 252. Richard, how do you get 2060?
I was doing mental math.
Okay, it was wrong. Check your mental calculator then. Alright, so what do I do now? Subtract what? Thank you, Nakira. Michael, thank you as well for 252. Now what? Divide by 80. So negative 252 divided by 80 is 24.8. What was it? Positive or negative? Negative. Richard, check your mental calculator game. We have 10 batteries.
There's a few more questions.
I wrote it backwards. So, guys, the final velocity of the male skater is negative 3.15 meters per second, right?
True.
So why is the male skater negative and the female's positive? Good, thank you, Marissa. Nice job, Michael. They're going in opposite directions, right? Thank you, Kevin. Does that make sense, guys?
I'm not Kevin.
I know you're not, Derek.
Do I have to bring a